So now we're looking at square arithmegons. They work exactly the same way. So if we look at this first one, we've got a 4 here in this circle. We know that we need to get 5 in the middle here, so clearly this one needs to be a 1. 4 and 1 gives us 5. Then to get 8 in the middle here, we'd need 7. To get 9 in the middle, we'd need 2, and then we just check 4 and 2 does give us 6. So that's good. So with this one, I'm going to go around this way. So I need 5 in the middle. I've got 3. So 3 and 2 gives me 5. To get 6 here, I'd need 4. 4 and 5 is 9, so let's put a 5 here and just check. 3 and 5 does give me 8. This one I'm going to go this way around, at least to start with. So I'm going to need 7 here. 1 plus 7 gives me 8. Now to get 5 in the middle here, I need to take 2 away from 7. So if I put negative 2 here, 7 add negative 2 gives me 5. 1 and 8 would give me 9, and just check that 8 take away 2 gives me 6, so those all work. Make 4 more square arithmegons that have the same box numbers as above, so this was the first one above, using only non-negative integers, so we can go from 0 upwards. Now the one we did above had a 4 in this box here, so that's the one we need to avoid. Now 5 is the smallest box number, so I'm going to start with a 0 here and see if I can get that to work. So this would need to be 5, this would be 3, and this would be 6, giving me 6 here, so that worked. So let's increase that number by 1. Then I can have 4, 4 and 5, and the 5 and 1 gives me 6, so that works. So let's try it with 2. So that would mean this one was 3. To get 8 I need 5 here, this would be 4, 2 and 4 gives me 6, so that works. And let's try 3. So this would need to be 2, this would be 6, this would be 3, and once again that works. Now we know that 4 works, so that's good. Now before I move on to the next bit, I just want to check whether I could do this with 5 here. So we could put 5, 0, 8 and 1, and that would give me 5 in the box, and down here I'd get 8 in the box, so that's good. 9 in the box here, and 6 in the box here. So I can do that with 0, 1, 2, 3, 4, which we saw above, and 5. But if I were to put 6 there, then I'd have to have negative 1 on the end, and I'm not allowed those. So I think actually that I've got all of the possible solutions. In general, the boxes can be labelled with the letters A, B, C and D as shown below. Complete the table below to show all of the solutions, no non-negatives. There may be more rows than you need. So remember, this one had a 5 here, we had an 8 here, a 9 here, and a 6 here. So in box A, we've seen that we can have 0, 1, 2, 3, 4, and 5. So 0, 1, 2, 3, 4, 5. And in B, we then had 5, 4, 3, 2, 1, 0, giving us this total of 5. Now if this one had a 5, to get 8 here, C had to have a 3, and then it would have needed 4, because it's these two middle columns that need to add to 8, then 5, then 6, then 7, then 8. And D needs to add with C to give us 9. So if C is 3, that would have given us 6, and then as this one goes up, this one needs to go down. 5, 4, 3, 2, 1. And that's all of the 6 solutions. So how many different square arithmegons do we think we can make with the box numbers as above if we only use non-negatives? So we've already discussed that. That's going to be 6. Explain the reasoning. Well, we did that. So A can be 0, 1, 2, 3, 4, and 5, and since the box number 5 was the smallest, we don't need to go into non-negatives. So we want a rule to determine the number of solutions that exist. Well, if we look at this one, we went for the smallest box number and we added 1 to get 6. And if you try that with the other ones above, you'll find that that formula does work. So that is our formula, the smallest box number plus 1.